Today we will see about the failure modes of flat steel plate which acts as a tension member. Basically, there are different patterns of failure that is being observed in tension members. So whatever we are using as tension member, for example, the plates could be used, or you can use steel sections such as angle section, channel section, I section, steel hollow sections for tension member. And these type of members have a definite failure pattern as observed from the research by the scientists. And these are being provided in IS 800 2007. And here we go. So what is tension and what is compression? It's the basic difference is between pull and push. So here you can see that the member is subjected to opposite forces which are in opposite direction. This is said to be pull, and that is tension. And if the opposite forces are just pushing the member, that is said to be in compression. Now these are steel trusses used in bridges. So many bridges in India we adapt and we go for steel trusses for the bridges. Here there is a goods train that is being traveling and it's crossing the steel bridge. Now you can observe that this is a very old bridge, and here you can find riveted joints. So these type of riveted joints are common in olden days where people preferred for these truss bridges. Now these type of rivets are being replaced by bolted joints and welded joints. The advantage of steel structures is that whenever there is a damage or the member gets worn out, you can replace the member by welding or riveting or bolting. So that is a very big advantage. And also the time consumption is very low as you compare it with the concrete structures. This is another typical truss bridge. So here you can see that this joint is a hybrid joint. This plate is called gusset plate. But the gusset plate is the mother where all the other plates are attached. You can find out that the other members are attached to the gusset plate. Now this is an angle section as you see. In between the angle section there is another plate that is being given here, and this it's being bolted. This is a hybrid joint where you got rivets as well as you got the bolts. Now these bolts are subjected to double shear. So double shear, single shear, all these type of shear is very common in bolted joints in trusses. Now this is a typical railway platform in India. Here you can see that this column is being the two steel sections are being connected by lacing in the both the directions. So typically it's an I section as you see from here, which is being connected by lacing. And also you can find out that this is a column which is being battened, and this column is supporting another beam which is also battened. So this type of battening is very common in railway platforms. And so in India the railway network is the largest among the world, and you can see that the whole network depends upon the steel structures for about 70 to 80% when compared with the concrete structures. And here also you can see a foot-over bridge. So a typical railway platform, a casual view of a railway platform, where you can find out that the steel structures are mostly used. And above this steel structure, you can find out that there is a shed made up of galvanized iron sheets. Now, this is a typical flat plate. It has a dimension of L into B into T. L is the length of the plate, B is the width of the plate, and T is the thickness of the plate. Gross cross-sectional area is B times the D, B times T. Now, this is a typical lap joint. You can see that one plate is sitting on the lap of the other plate. So this is a typical lap joint, and failure has already occurred. This is subjected to single shear as you see. Now, what are the different modes of failure in tension members? You can see that it's gross sectional yielding, net section rupture, and block shear failure. And among these three, we will decide the vulnerable load based upon which we will be designing the tension member. Now let us see an animation video of a bolted joint. So these arrow marks represent the tensile pull. So it's a typical lap joint. Now it's bolted and the bolts are subjected to single shear. Now the same figure is shown here. So this is the tensile pull and you can see the bolted lap joint here. Now gross section yielding. What is the meaning of gross section yielding? Definitely it has some holes if you connect it with rivets or bolts. But even then, after connecting with bolts or rivets, suppose the failure does not happen because of the bolts and the failure happens because of the plate, this type of failure mode is called gross section yielding. So here we go. So here you can see that the bolts are not failing. The failure is occurring in the gross cross section. So the whole cross section has yielded. Now it's an arbitrary pattern. We don't know how exactly it will fail. So it's an arbitrary pattern. Now this is said to be gross section yielding. Bolts don't fail. The plate gross cross section fails. Now the next type of failure is net section rupture. So let's see the video. Yeah, clearly you can see the net section here. That means gross cross section minus area of the bolt holes. Yeah, now you can find out the difference between the gross section and net section. So in the previous video you have seen the animation where the plate fails. Here also you can see that the plate fails, but the area of the cross section is not the gross cross section but the net section. So what is net section? The total area subtracted by area of the bolt holes is said to be net section. Yeah. So this clearly indicates that this shaded red portion is the net area. So what we have done is we have subtracted the longitudinal area of the bolts. Here we are not subtracting the cross sectional area but longitudinal area of the bolt holes. So these longitudinal area of the bolt holes are subtracted from the total area, that is the cross section area, where you are obtaining the net section area. Now here it's nothing but the net sectional area is defined, where you are subtracting the gross cross sectional area, subtracting the area of the bolts from the gross cross section and obtaining the net sectional area. Yeah, this is a typical example that you can see. Net area equal to gross cross sectional area minus the area of the bolt holes. So the calculations are given. Now we will move on to new type of failure called block shear failure. Previously in old code IS 800 1984, we did not account for block shear failure. But after the release of IS 800 2007, we take into account the block shear failure. So here goes the animation of block shear failure. As you observe that, here it is the failure which is concerned with the shear, and this part is subjected to tension. So this is a case which is a combination of shear failure along two lines. That is along this line as well as along this line. You can see that the failure is taking place due to shear, and this cross section will show you that at this location the failure is due to tension. So the combination of both will give you the block shear failure. Yeah, this is beautifully explained here by the animation. Now what is the design load? The design load in the sense, we identified three modes of failure. One is the gross cross section, another one is the net section, the third one is the block shear. But the point is which one to design. So obviously we will decide the least among the three. So the first one is the gross cross sectional area, which is due to gross cross sectional area. We will calculate the design load. And the second one is due to the net cross sectional area, and the third one is due to the block shear. And the least among this, for example, if you have the gross cross sectional area, if you get 50 MPa, and net cross sectional area if you get 40 MPa, and block shear you are getting 35 MPa, definitely you have to take into account the that is the strength of the plate, strength of the connection, or the design strength of the plate is nothing but 35 MPa. So that is what we will decide. 35 MPa is the stress, and you can multiply it with the area of the block shear and obtain the design load. Definitely, because the point is it will fail by 35 MPa, and above 35 MPa, even if you try, it will not take any load. So the point is, least of these three is the design load. So activity 1, you can calculate the net area, and activity 2, here you can see that I want you to identify what type of failure it is. Thanks a lot for watching. So here you can see that this is a simple fin type truss, and this is fan type truss, simple fan type truss, and this is compound fin, this is prod type. So this prod type and Howey type, or Howey type of trusses are mostly used in India. That is Pratt truss and Howey truss. Compound fink is also preferred for larger spans. Thank you for watching. If you have any doubts and queries, please mention in the comment section. Thank you.